Okay, we retain another integral. This one's from the Vienna integration bee 2024, problem 15. We have the integral from 0 to infinity, natural log x over x squared plus 1 dx. Okay, when I was working on this, I found there was just a lot of different ways to approach it. Didn't really matter too much which way I did it, but what I want to do, just notice when we have bounds going from 0 to infinity, this is a good case where we can use the u substitution, setting u equal to 1 over x. Then taking the reciprocal on both sides, we can isolate x. We have x equal to 1 over u. Then just take the derivative. Dx here is going to be minus 1 over u squared du. Then we'll just go ahead and substitute right now. First, if you take infinity, plug it in somewhere, plug it in right there. 1 over infinity, that part's going to be going to 0. And then for the lower bound, you plug in 0. When we have 0 in the denominator, that's going to be going to positive infinity. Then for the numerator, we're going to have natural log of 1 over u. You can break it up with log properties, so you can look at this as u to the minus 1 power. Actually, let's just break it up. So if we do it like natural log 1 minus natural log of u, natural log of 1 is 0, and we just get minus natural log of u here in the numerator. Then looking at x squared plus 1, this is going to become 1 over u squared plus 1, and then we have our dx. That's going to become minus 1 over u squared du. Let's actually take care of this minus sign. If I get rid of this, I can bring this out front and use it to swap the bounds. So then now I can have this integral going from 0 to infinity. I'll take this u squared and let's distribute it in. And I think I'll take this minus out front of the integral. So when I rewrite this, we'll have minus 0 to infinity, just natural log u here. U squared times 1 over u squared, that's going to be 1. And then this is just going to be u squared du. But now with this being a definite integral, I can do a variable change on this. Let's change the variable back to x everywhere. And then doing that, what do we notice? This right here, this is exactly the same as what we have right here. The denominator is in a different order, but that doesn't bother us. We do have this minus sign over here, however, so let's put some labels on it. For the original integral, we'll call this I. We transform it down here all the way. But now with the minus sign in front, this is minus I. So just to make it clear what's happening, we have this equation I equal to minus I. If you want, you can add an I on both sides. And then what we have here is we have 2I equals 0, which means that I is just equal to 0. And so my final solution for this is just going to be 0. One note on the solution, if you do the trig substitution for x equal to tan of t, what would happen is you would get an integral that we actually did like 4 or 5 days ago, which is just 0 to pi over 2 of natural log tan x. And that one also came out to 0. Okay, there you have it. Another good one from Vienna 2024. Thanks everyone for watching. Have a good day.